Okay, so now let's get to exercise 15.3, which is basically we have a group of data, and we want to state which group is more variable. So the groups are basically something like this. So you have basically your marks over here. Actually, I do need some more space over here, and before we start, okay, so you need these groups over, you have these groups over here. You have basically these marks, and then you have the groups, group A and group B. You have the marks and group A and group B, and then the marks are 10 to 20, then 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. And then the frequency of these marks related to group A are 9, 17, 32, 33, 40, 10, and 9. And then you have 10, 20, 30, 25, 43, 15, and 7. So that's the data that I have. And you want to know which group is more variable. And before we start, let's have a clear understanding and roadmap to what we want to do, because these kinds of things tend to get pretty lengthy, meaning that it usually takes, for example, something like this, if I'm not tired, at least 45 minutes or so to go through these two problems. So what in the case of these two examples, basically in the case of these two groups, you have basically two distributions. Now we said that basically we came up with the definition that the coefficient of variance or variation is equal to sigma over x bar times 100. Meaning that if you have the standard deviation of some distribution and the mean of some distribution, if you get the ratio of those two and multiply that number by 100, then you will get some number over here. For example, some number like 7 or 10 or 12 or 15 or whatever, some number you will get over here. And I don't think the number can go above 100, because this is almost always going to be, this fraction is almost always going to be less than 1. I suppose I'm not sure about this, and I'm not thinking about this mathematically, but I mean, I'm not considering any cases or anything, but usually based on what I've seen is it's almost always less than 1, and then multiplied by 100 you will get some number less than 100 because this number is either 0.2, 0.3, 0.5, 0.7, and so on and so forth. Now that part is not important. At the end of the day, you will get some number over here. And then you can, of course, you can calculate this, for example, for group A, you can calculate that for group B, and of course, the two numbers, the two coefficients of variation, you can use it in the case of distributions where the mean is the same, meaning that you don't use this kind of thing for the kind of distributions where the means are displaced. If the mean is displaced, so what this number is telling you is what the standard deviation is telling you is some measure of dispersion about the mean. And so, for example, suppose that for group A, your sigma is equal to, for example, your sigma is, for example, 5. For group B, suppose that your sigma is, for example, 7. Now, how you make sense of this number? This is the measure of dispersion. It's number 5 or 7 or whichever one you consider. Or let's consider this one, sigma is equal to 5. That number is a measure of dispersion about some mean. Measure of dispersion about some mean, for example, x of 1 bar. And the same goes for this number. This number is also a measure of dispersion about some mean, for example, x2. So this is also some measure of dispersion about some mean x2 bar. Now, if these two if basically if x of 1 bar is equal to x of 2 bar, then of course it makes sense that you basically that you compare these numbers and say that, for example, the measure of dispersion for group A is compared to group B is basically these two numbers. So that means that basically for group B the measure of dispersion is higher, or your data is more variable about some mean x2, and that basically x2 bar is the same number as x1 bar, meaning that you're considering that dispersion about the same basically mean. But suppose that I say that, for example, the measure of dispersion of suppose that I say that basically using the same formula, suppose that I say that the measure of dispersion of this data about some mean, for example, 5 is suppose that let's say that the measure of dispersion or the coefficient of variance of this data about some mean is equal to 5, and the measure of dispersion of this data about some mean is 7. In this case, x bar is equal to 5 or 4. In this case, for example, in this case, your x bar is equal to 4.5. So of course in these two cases this comparison doesn't make any sense, because those measure of dispersions are relative to different X bars, and so that doesn't really mean anything. You wouldn't do that. So that's basically the whole story here. That means that when you want to compare one measure of dispersion to another measure of dispersion, those two coefficients of variation have to be relative to the same X bar. Otherwise, you just don't compare them together. It's not that they're wrong or anything. That is one CV related to some distribution. That is some other CV related to some other distribution. Now, if in two distributions the X bars happen to be the same, then of course you can go in and basically measure the two CVs. Otherwise, you just don't compare them, because it doesn't make any logical sense. And of course, in case, for example, let's say that, for example, the coefficient of variation of some data is some number relative to some X bar, and the coefficient of variation of some other distribution is some other number related to the same X bar. Well, if that's the case, then you don't really need to worry about calculating this whole thing. Then you can, meaning that you can, if it's the case that, for example, if it's the case that CV1 is equal to sigma 1 to X bar times 100, and CV2 is equal to sigma 2 divided by the same X bar times 100, then of course basically the measure of dispersion is going to be higher here if, for example, sigma 1 is greater than sigma 2. Meaning that if you calculate your X bars and they happen to be the same, then you can just simply calculate sigma 1 for this first distribution, calculate sigma 2 for the second distribution. If sigma 1 is greater than sigma 2, then you can say that your data in the case of the first distribution is more variable, or you can say that your data in the first of the second distribution is more consistent, and vice versa, of course. So that's basically the whole story. So that since these sigmas are in the numerator, whichever one is greater than the value of CV over there is going to be greater. So you can just simply compare the sigmas, and then that becomes your measure of, that becomes how you decide the coefficient of variation in the case of those two distributions. So now what I'm going to do is that I'm going to calculate, basically, first of all, I'm going to calculate the X bar for group A, and I'm going to calculate X bar for group B. If they happen to be the same, then I will go in and calculate sigma 1 for group A and sigma 2 for group B, and then we will compare those two, and then we can say whether one distribution is more variable or not. So that's what I'm going to do. So now let's start with the X bars. And in order to do so, since I need to draw some of these tables and everything over here, and I want to use the shortcut method. So in the shortcut method, you know that you need to have your groups over here, and then your classes over here, and then you need to calculate y of I and the whole business over there. So then I'm going to draw a table over here for group A. And for group A, I'm going to basically I'm going to write these marks over here, which basically are nothing but my classes, which go from basically 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. And then over here I write group A, and that serves as my frequency f of I. And so that's 9, for example, 17, 32, 33, 40, 10, and 9. And now I want to and it's very simple. I just want to calculate x bar over here. And I want to calculate x bar using the shortcut method, because in the shortcut method you get to calculate standard deviation in the same procedure as well. Meaning that in the shortcut method we said that x bar is equal to, for example, a plus h times y bar, and also sigma of the standard deviation of variable x, we said that it's equal to h divided by n times the square root of n times sigma f of I y of I squared as I goes from 1 to n, minus sigma f of I y of I as I goes from 1 to n, and you square this thing, raise it to the second power, and that becomes your sigma of x, the standard deviation of variable x, which we can calculate here. The variable x, we can calculate it here. So since I want to use the shortcut method, I have to calculate basically my x of I, my y of I, then the x bar and then the y bar and the x bar, and so on and so forth. So what that means is that based on these marks that I have here, I calculate the class marks. And the class marks will serve us as the x of i's, and that is nothing but the average of the lower limit and the upper limit of these classes. For example, here you get a 15, 50 divided by 2 is equal to 25, 7 divided by 2 is equal to 35, 90 divided by 2 is equal to 45, 110 divided by 2 is equal to 55, and so on and so forth, 65 and 75. So these are your x of i's. And then to calculate y bar, you know that basically y bar is equal to, since basically x bar is equal to sigma f of I x of I divided by sigma f of I, then of course if you write this as y and y here, then this becomes y bar. That means that to calculate y bar I need to have y of I. And y of I, to calculate y of I, we said that in the shortcut method what we do is take some value over here as the assumed mean of the data. For example, I take a as the assumed mean of the data, and the class size over here is 10. H is equal to 10. And so in order to make this class mark or these x of i's basically smaller, I take my x of I, subtract from that the class subtract from that the assumed mean of the data, which is 8. And then divide that whole number by the class mark, by the class size, which is h, in order to make it further smaller. And then we call this y of I. So now I need to calculate this y of I for all of these x of i's. So y of I, which is nothing but x of I minus a divided by h, is equal to, you can basically use the same basically logic here. X of I is basically 15 minus 45, for example. 15 minus 45 divided by the class size, which is equal to 10, for example. And 45 minus 15 is equal to, basically, or 15 minus 45 is basically 50, and then negative 30 divided by 10 is equal to negative 3. Negative 3. The second one is 25 minus 45 divided by 10, so that's equal to 20 divided by 10 is equal to 2. 35 minus 45 is equal to, minus 45 is equal to basically 10 divided by 10 is equal to 1. Here you get a 0, here you get a 1, here you get a 2, and here you get a 3. The next thing that we have is, so now that you have calculated your y of I, you need to calculate y bar. And y bar is nothing but sigma f of I y of I divided by sigma f of I. So I calculated f of I times y of I here. F of I times y of I here. So I have basically 9 times 3 is equal to negative 27. 17 times 2 is equal to 34. Actually, that's supposed to be negative 34. And just to make sure that I'm not doing the wrong, or calculating, 17 times 2 is equal to 34. 1 times 32 is equal to negative 32. 0, you have 40, 20, and 27. And then since I need sigma f of I y of I need sigma f of I y of I have to add all of these numbers together. So that would be basically 5 and 8, so that's an 80, negative 80, and then 11 plus 2 is equal to 13. So you have 13 here as well, so that's negative 93. And over here I have a 60 and 80, 87. Positive 87. Now 93 minus 87 is equal to 8, 13. What is 13 minus 7? So 10 plus, no, 7 plus 7 is equal to 1, 6 plus 7 is equal to 13. So now negative 93 plus 87 is negative 6. Is negative 6. So that means that the sum of all of these numbers becomes negative 6. So sigma f of I y of I is equal to negative 6. And sigma f of I over here, which is the sum of all of these numbers, sigma f of I is equal to 9 plus 17 is equal to 26, 32, 73, 83, 92. So you have 73, 83, 93, 92, and you have 6 plus 4 is equal to 10, 1, and 6 plus 9 is equal to 15, 150. And you can now calculate your y bar. So your y bar is equal to sigma f of y y of y, which is equal to negative 6, divided by sigma f of y, which is equal to 150, divided by 230, divided by 275. So that's, and 3 by 3, 1, 75 by 3, 25. That's negative 1/25. So your y bar is equal to negative 1/25. And now based on that, I can calculate x bar, because x bar is equal to a plus h times y bar. So x bar is equal to a, which is 45, plus h times h is equal to 10 times y bar, which is negative 1/25. And divide by 5, 2, divide by 5, 5, so that's negative 2/5. That's 45 minus 2/5. Now, 1/5 happens to be 10 divided by 5 is equal to 2, so that's 0.2. So 2/5 is, so then 2/5 is 0.4. See, 1/5 is equal to 0.2. That means that 2 times 1/5 is equal to 2 times 0.2, which is equal to 0.4. So that is 45 minus 0.4, which is equal to 44.6. 44.6. So your x bar is equal to 44.6. Okay. Now I'm going to leave this here as it is, since I have now calculated my x bar, the mean of the data. I'm not going to calculate this one right now. And then I'm going to go basically I'm going to form another table, do the same thing for group B. Now if the x bars happen to be the same, then I will come back here and calculate standard deviation for this data and the standard deviation for group B as well, and then we can compare them. Otherwise, if the x bars happen to be different, then there is no point in calculating the standard deviation. So that's what I'm going to do now. Okay, so now I'm going to do the same thing for basically group B. So the class marks are going to be the same, but y of I is, you see, y of I is basically x of I minus a divided by h, which remains the same, but f of I times y of I is not going to be the same. So I can copy these basically 4 columns as they are, and then I have to calculate this fifth column. So let me take these 4 columns and put them over here. So these are the marks. This is group B. This is the class marks, and this is the y of I. And this is going to be f of I times y of I. So these are the marks. This is group B. This is the class marks. This is y of I. And this is f of I times y of I. Actually, I did need a little more space over here. I couldn't. And this software I cannot. Well, that's okay. So 10 to 10, 10 to 20 is going to be here, 20 to 30 is going to be here, 40 to 50 is going to be here, 50 to 60 is going to be here, 60 to 70 is going to be here, 70 to 80 is going to be here. And then group B would be basically these numbers. So now I have to write 10, 20, 30, 25, 10, 20, 30, 10, 20, 30, 25, and 43, 15, 7. I've forgotten something here. And I'm going to write it 30 to 40. Then we have 40 to 50, 50 to 60, 60 to 70, and 70 to 80. And then we have 3 f of i's left, which are 43, 15, and 7. And then the class marks are 15, 25, 15, 25, 35, 45, 55, 65, and 75. And we took this as A, and the y of i's remain the same because they depend on A and H. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. And f of I times y of I would be, so this would be f of I, this is x of I, and this is y of I. F of I times y of I is negative 30, negative 40, negative 30, and that's 0, that's 43, that's 15. Sorry, that's 43, that's 30, and that's 21. So that's 70 and plus 30 is equal to 100, negative 100. It's 73, 93, 94. So negative 100 plus 94 is equal to negative 6. So sigma f of I, y of I is equal to sigma f of I, y of I is equal to negative 6. So now what I need to do is calculate basically x of I here. We said that x of I is equal to basically a plus h times y of y bar. So your y bar is equal to sigma, your y bar is equal to sigma f of I, y of I, divided by sigma f of I. And sigma f of I is over here, sigma f of I is equal to 30 plus 30 equal to 60, 85, 85, and you have basically 58. 58 plus 7 is equal to 58 plus 7 is equal to 565. And these two numbers added together, you will get 150. 150. And So your y bar is equal to sigma alpha y of y, which is equal to negative 6 over sigma alpha y, which is equal to 150. Divide by 2, you get 3. Divide by 2, you get 75. 1 to 25, so that's negative 1 to 25. Y bar is equal to negative 1 to 25. The next thing that we have is x bar is equal to 8 plus h times y bar. So your a is equal to 45, so your x bar is equal to 45 plus h times h is equal to 10 here, the class size, and y bar is equal to negative 1 to 25. Divide by 10, you will get 2. Divide by 10, you get 5. Negative 2/5, so that's 45 minus 2/5. 2/5, we showed that it was 0.4, so that's 45 minus 0.4, which is equal to 44 minus 6. So your x bar is equal to 44.6. 44.6. So now, since the mean of the data is basically x bar and x bar here, which is basically 44.6, what we can do is that we can calculate, since the mean of the data is the same, what I can do is that I can calculate the standard deviation of the data in the case of basically this data over here and this data over here, and then compare those two because the mean is the same. So here we said that I'm going to calculate the basically sigma f of I y of I squared over here. F of I y of I squared is going to be, for example, 9 times 9 is equal to 81, and 4 times, for example, 17 times 4 is equal to 40, 28, so that's 68. Or you have, for example, 1 times 32 is equal to 32, 0, and then you have y of I here is equal to 0. 1 times 40 is equal to 40. 4 times 10 is equal to 40. And 9 times 9 is equal to 81. Add these numbers together, you will get, you get 140, 170. And then you have 9 plus 2 is equal to 11. And then over here you have 80 plus 8 is equal to 161. So you'll get 2, you'll get 14, 1, and 342. So that means that sigma f of I y of I squared is equal to 342. And we also need sigma f of I y of I, which we have calculated. So I can calculate sigma of x as h divided by n. So my h is equal to the class size, which is equal to 10. And n is equal to sigma f of I, which is equal to 150. Times the square root of n, which is equal to 150. Times f of I y of I squared, sigma f of I y of I squared is equal to 342. Minus sigma f of I whole squared. Sigma f of I y of I whole squared is equal to 36. So what that means is that this is 1 to 15, and 15 times 342 is 342 times 15 is equal to, and you have a 0 there, So 5 times is equal to 10, 1, 20, 21, 2, 15, 17, 0, and 342. 0, 3, 11, 1, and that's a 5. And then you have a 0 over there, so that's 51,300. Minus 36 is equal to basically 2, 9, and 10. So 10 minus 6 is equal to 4, 6, 2, 1, 5. 5, 1, 2, 6, 4. So that's the square root. So that's 1/15 the square root of 31,264. Now the square root of 31,264. Okay, so I did this calculation. It seems that it was wrong so let's do it again. So you have the square root of 31,264. So 31,264. Group them this way. And now 1 times 1 is equal to 1, so subtract, you get a 2, and 12 comes down. Now 1 plus 1 is equal to 2, 1 digit here, 1 digit here, so you have 29 times 9 is equal to, so around 270, 27 times 7 is equal to 1489. And 28 times 8 is equal to 64, 6, and 16 plus 6 is equal to 224. So you have to go with 170, basically 17 and 70. And you have 189. If you subtract here, you will get basically 1, 11, 10, and 12 here. 3 and 2. And you can bring down 64. 23, 64. So now you have 27 plus 7. 27 plus 7 is equal to 34. 34 and 1 digit here, 1 digit here. So you have basically something around 340 times some number is going to be equal to something about 2300. So I would say 6 times 34 times 6 times 6 is equal to 1800. And 240, that's 36. So you have a 6 here, you have a 7 here, you have a 0, and 2076. And 347 times 7 is going to give you 2100, 28, 0, and 49. You have a 9 here. You have 12, 1, 4, and 2, 2, 4, 2, 9. So I have to go with 6. And I'll get a 2076 here. If I subtract, I will get a 2, basically 16, 15, and 14. 8 plus 6 is equal to 14, 8 plus 7 is equal to 15, and you get a 2 over here and a 0 there. So that is 176. That so far we have no problems. Now I put the decimal point here and 2 zeros here, and 2 zeros here. So I have 28,800 and this was, I suppose, 6. So 346 plus 6 is equal to 2,153,52, and 1 digit here, 1 digit here, and you have 3,500, and this is around 30,000. So 6 times, for example, 3,000 is 8, no, basically 5 times, that's 15,000. 5 times 3,000 is equal to 15,000. 5 times 500 is equal to 2,500. So that's about 17,000. 7 times 3,500 is 21,000, and 3,100, which is 24, basically something about 24,500. And 8 times 3,500 is equal to 24 and 3 zeros, and then that's 42 zeros. That's 28,000. And then I think 8 is going to be the answer here. So 352, 8 times 8 is equal to 64. So 8 times 8 is equal to 24, and 3 zeros, 42 zeros, and you have 16 1 0, and you have 64 0, I'm sorry, 4, 12 1, that's a 2 8 2 2 8 2 4 2 2 4. So you have basically 3528 times 8, 28224, 28224. And so that was 8 times. 8 times here. And if I subtract, what I will get is basically 7, 9, and 10, 6, 7, 5, and 0. If I go for another 2 zeros, I have basically here 3, 5, 2, 8 plus 8 is equal to 16, 1, 3, 5, and 3. So that's 3, 5, 3, 6. 3, 5, 3, 6, and another digit here, another digit here. And so you have around 35,000, and this is 57,000. So if I go 2 times, that would be at least 70,000, which is not possible. So you have to go for basically 1 time. So then I don't have to do the calculation anymore. You'll get some number over here and some remainder. So I think I can take this as 176.8. So that's 1/15 times 176.8. So that's 176.8. 176.8 divided by 15. Now to do this calculation, so what I need to do is 1 times 15 is equal to 15, 2 remainder 6, bring it down, and 1 times 15 is equal to 15, that's 1 and 1, 11 times, 11 or 11 basically, and then decimal point 8, that's around 120. So 7 times 15 is equal to 70, and 35, 105. 15 times 8 is equal to 80, and 40, 120. So I have to go for 7, and that's 105. So 3, 1, and 0. Another 0 here, another 0 here. Can go for 8, and I will get some remainder here, so I take this as 11.8. I take this as 11.8. So the standard deviation here is 11.8. These are let me see if I have done this right, and then we will move on to the next. It seems that I have actually made let me see. Okay, so it seems that I have made a mistake here. So the square root of 150 times 342 minus 36 is supposed to be 51,264, not 31,000. So then if I calculate that, I'm not going to go into the calculation anymore, because I have done the whole thing once. There is no point in doing that anymore. So basically the square root of 51,264, and if you divide that by 15, you will get 15.09. 15.09. So I correct this here. I don't know how I made this mistake. Seems that I did make this mistake the last time as well. So let me see. Let me make a screenshot here. So, but at the end of the day, this is going to be basically 15 times. This is going to be 1/15 the square root of 51,264, which happens to be 15.09. That's the value of standard deviation here. Now let's go and see why I made this mistake. So 342 times 15 is equal to 5 times is equal to 10, 1, 20, 21, 2, 15, 17, 0, and 342. If I add these two numbers, I get 3, 11, 1, and that's 5, 1, and then there is a 0 there, so that's this number. And if you subtract this 36 from this, you will get basically 2, 9, and 10, and then 4, 6, 2, 1, 5, 5, 2, 5, 1, 2, 6, 4. And then if you divide that number by this number, you will get 15.09. Okay. So that's the standard deviation here. Now the standard deviation for this, for group B, the standard deviation for group B is going to be equal to, basically, again, we said that basically sigma of x is equal to h over n times the square root of n times sigma f of I y of I squared minus sigma of f of I y of I whole squared. That's your sigma. Now I know my h here, which is the class size. H is equal to 10, n is equal to sigma f of I, which is equal to 150, and sigma f of I y of I squared I have to calculate. This I have already calculated, so the only thing that remains is sigma f of I y of I squared. So f of I y of I squared is equal to 9 times, for example, 10 is equal to 90. 4 times 20 is equal to 80, for example. And 1 times 30 is equal to 30. And 0 times 25 is equal to 0. And 1 times 43 is equal to 43. 4 times 15 is equal to 60. And 9 times 7 is equal to 63. If I add all of these numbers together, we get 170. 170 plus 30 is equal to 200, 243. And let's take this at 200, 103 here. And 63 here, you'll get 6. A 6 there, and 366. So sigma f of I y of I squared is equal to 366. Okay, so now what I can do is I go over here and basically put all of these values in this formula. So sigma of x is equal to h, which is equal to 10 over n, which is equal to 150, times the square root of n, which is 150, times sigma f of I y of I squared, which is equal to 366, minus sigma f of I y of I whole squared, which is equal to 36. And now we need to calculate this thing over here. So that's 1 to 15. And that's 366 times 15 and a 0 there. So that's 5 times 6 is equal to 33. 30, 33, 3, 15, 18, 0. And then you have 366. 0, 9, 14, 1. And that's a 5. 5, 4, 9, 0. And you have another 0 there. And if you subtract the 36 from that, you would get 8, 9, and 10. 10 minus 6 is equal to 4, 9 minus 9 minus 3 is equal to 6. You have 8, 4, and 5 here. So you have 1/15, the square root of 54,864. So that's your number there. Now we need to take the square root of this number. The square root of this number is 54,864. Group it like this. And then we have basically 2 times 2 is equal to 4. 1 remainder, 48. And then 2 plus 2 is equal to 4. 1 digit here, 1 digit here. So for example, 45 times 5 is equal to around 200. 44 times 4 is equal to 160. 176. 43 times 3 is equal to 120. And 1232. 132, so that's a 3 here. And if I subtract 8 minus 2 is equal to 6, 1. And then you have 6 and 4 here. So I have 43 plus 3 is equal to 46. One digit here, one digit here. We have around 500. So 3 times 4, 6. 3 times 3 is equal to 9, 18, 1, 12, 13. That's around, okay. So that's 3 and 3 here, 13, 89. And if I go for this 5, 16, 15, and 14. 14 minus 9 is equal to 3. 15 minus 8 is equal to 7, and that's 273. Decimal point 00, bring it down, 00. And 463 plus 3 is equal to 466. One digit here, one digit here, one decimal point. This is around 500. That is basically 27,000. So 2 times 27,000 would be around 40 and 54,000. So this is something around 5,000. Divide 20,000 by 5,000 and get something around 4 times. So 4 times, so 4, 6, 6, 4 times 4 is equal to 16 and 3 zeros, 24 2 zeros, and 24 1 0, 24 1 0, and 16. And you will get basically a 6 over here, a 5 over here, a 6 over here, 8 and 1, 18,656. I'm not sure if that's correct. 4664 times 4 is equal to 18,656. That is correct. Now 4665 times 5, that's around, that's the same thing as 20 and 3 zeros, 24 2 zeros, and 31 0, and that's a 25. That gives me basically 5, 2, 7, 2, and 2. That's 22,000. Okay. That's also, I mean, that you could use as well. Times 5 is equal to 23. 4665 times 5. 23 zeros, 30 and 2 zeros. That's supposed to be a 3 0. 31 0 and 25. So you would get a 5, you would get a 2 here, you would get a 3 here, a 3 here, and 23, 325. This is also correct. But of course, if I go for 4666 times 6, I would get 24 0 0 0, 24 0 0, 24 0, and 24. I have a 4 over here, I have a 6 over here, and so these are all together, so 4 plus 2 is equal to 6, 4 plus 2 is equal to 6, so 26,664, that's actually interesting. Okay, so 4666 times 6 is equal to 27. 6 times 4 is equal to 24 and 3 zeros. 6 times is equal to 36 and 2 zeros. Let me do this again. So we have 4 times 6 is equal to 24 and 3 zeros. 6 times is equal to 36, 2 zeros. 6 times 6 is equal to 36, 0. 6 times 6 is equal to 36. So I have a 6 here, a 9 here, a 9 here, and a 7 here, and a 2 here. 2, 7, 9, and 6. So this one doesn't, I mean, this is correct actually, but it's larger than this number. So I have to go for 5. So that's a 5, and I will get basically 23325. 23325. It's very easy to make mistakes. You need to be very careful. Okay, so now what I can do is that I think I can, sometimes borrowing doesn't work in some cases, but I think in this case it might work. So make this a 6, a 13, 12, 9, and 10. 10, that's a 5, that's a 7, that's a 9, that's a 3, and that's it. Now if you use another 2 zeros here and add basically 4, 6, 6, 5, add 5, that's a 4 actually. 4, 6, 6, 6, 4, 6, 6, 5, add a 5 to it. You will get a 0 here, 7, 6, and 4. 4, 6, 7, 0. 4, 6, 7, 0. And 1 digit here. And 1 digit here. And you have 397,000. That's around 400,000. And that is around 500,000. So if you had basically 400,000 and divided that by 500,000, what would you get? 3 zeros, 3 zeros, 2 zeros, 2 zeros. Well, that is actually, it's actually 50,000, I'm sorry. So if you had around, if you had 400,000, divided that by 50,000, so 3 zeros, 1 0, 1 0, and that would be 8 times, right? So I'm going to try 8 times here. So, and of course I have all of these numbers over here, which might actually work out to be 7 times. So let's go with 7 first. So 46707 times 7, that's 49, 4. 6 times 7 is equal to 42, 46, 4, and 28. 28 plus 4 is equal to 32. 32. So 76707 times 7 is equal to 53,000. I'm making mistakes here. 7 times 7 is equal to 49. 7 times 7 is equal to 49 of 4. 7 times 6 is equal to 42. 46. 4. 7 times 4 is equal to 28. 28 plus 4 is equal to 32. Right? So 76707 times 7 is equal to now I'm making a mistake here. So 7 times 4 is equal to 28, right? 7 times 4 is equal to, that's a 4670. So 7 times 4 is equal to 28, and you have 4 zeros there. 7 times 6 is equal to 42 and 3 zeros. 7 times 7 is equal to 49 and 2 zeros. That's a 0. 7 times 0 is 49. Add all of these numbers together, you get the 9. You get the 4 here, you get the 9 here, you get the 6 here, you get the 12 here, 1. 3, 2, 6. I don't understand. Well, that's actually correct. 7, 6. No, that's actually correct. So that's 7 times, and you get the 7 over here. You get 32,000, 32, 6, 9, 4, 9 here. You get some remainder here. So I take this as 233.6. So that's 1/15 times 233.6. And if I take the square root of this number, let me see what I will get. SQRT of 548,548,64, 234.2. 54864. 54864. 234.23. Okay, I might have made a mistake there. Anyway, let's take the square root of this number, as I have made a mistake here, which is, well, okay for now. I don't really want to go back there and see what the mistake was. So I take this as 200. Well, let me check. 54864. So that's 234.23, right? And if you divide this number by 15, 234.1.23 divided by 15, what you will get is basically 1 times 15 is equal to 15. So that's a 1, and that's a 13, so 8. And so that's something like 3 times 15 is equal to 15 times 3 is equal to 15, 1, 45, no. 15 times 5 is equal to 50 and 75. So that's 575. And then you will have basically 7 and 14. 14 minus 5 is equal to 9. And of course, the decimal point goes over there. And then you have a 2 over here. So 8 times 15 is equal to 80, and 40, that's 100. Oh, 8 times 1 is equal to 80, 8 times 5 is equal to 40, that's 120. So 7 times 15 times 7 is equal to 70 and 305. And 6 times 15 is equal to 60 and 90. So that's a 6, and you get a 90. 2 remainder, 3. and 1 times 15 is equal to 15, some remainder, so you get 15.6 equal to 15.6. That is your standard deviation. That is your standard deviation. Now the standard deviation, as you can see here, is 15.6, and the standard deviation is 15.09. So since the x bar over here is 44.6, x bar over here is 44.6, the x bars are equal. So you can say that since the standard deviation here is, the value of the standard deviation is higher here, therefore the data in the case of group B is more variable. Is more variable. It took us a long time to calculate this, but well, it was worth it. So I'll see you in the next video with question number 2.